This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new edition of the Industrial AI podcast. My name is Peter Seeberg, and today I will be talking to Yuchen Xia.
Yes, thank you.
And we're going to be talking about the large language model multi-agent systems, specifically for simulation model parametrization in digital twins. Hello, Yuchen.
Hello, Peter. Nice to meet you.
So first, I did ask you, did I pronounce your name correctly? Yuchen Xia.
Yeah, that's perfectly fine.
Cool. I hope I'm going to keep it as good as this. Very good. Please tell us who you are and what you do.
Hello, everyone. I'm Yuchen Xia. I'm a researcher at University of Stuttgart. Since 2021, I began researching about how to incorporate the large language model for industrial application under the supervision from Professor Michael Weihich and with the help with Dr. Nasser Yazdi. And I began this research since 2021. At that time, people hardly ever heard about the large language model, and people get confused why I try to combine the natural language processing with industrial automation. It's completely two different domains. But with the time, I just followed my trace and evidence from the observation in my research and kept this direction. And since 2023, there is a huge tech wave that was created by ChatGPT, and people gradually believe me. And it's quite a long history. Before my acknowledgement from the community, there are already 2 years of struggling to find the correct direction and try to find the value.
That's very good. I like that very much. You must have received a shitstorm, 1 or 2, like I have had as well, but not, for similar, let's say just for similar reasons. Whenever you like me like you, were showing that we believe things were going a certain direction, not always everybody is happy with that. So very good that you stick to your direction. We had actually been in contact already about a year ago, right? And you told me, quote unquote, you were busy conceptualizing, implementing a new system design for applying LLM in solving engineering tasks autonomously. I love that word, autonomously. We're going to get to that just in a moment, as a part of my dissertation project. And then you also said that there are still some hard, inescapable problems left. And I'm spending days and nights thinking, drafting, and programming to focus on solving them. Quote, stop. And I'm sure that today we're going to hear from you how you did, in the end, solve those, what at that time looked like inescapable problems. So we agreed to stay in touch. And it was only a couple of days back that Robert actually made me aware of a LinkedIn post you already mentioned by Michael Weihich. He's the director of your institute. We come to that in a moment. And he announced the paper by a team of authors led by yourself, also with contributions of Daniel Ditter, Nasser Yazdi, Haonan Chen, and himself, titled, as is the central theme for today, Large Language Model Multi-Agent System for Simulation Model Parametrization in Digital Twins. And this paper had won the Best Paper Award during the IEEE EFTA 2024 International Conference on Emerging Technologies and Factory Automation in Padova, Italy. Wow, that was a mouthful. So, congratulations again. Now, before we get into your paper, which is, as I said, really the topic of today, why do you not first maybe give a quick introduction into the Institute of Industrial Automation and Software Engineering at the University of Stuttgart?
Yes, in our institute, we are researching on how new technology, including AI, of course, also the large language model, can contribute promoting the industrial automation technology further. And this paper is just one use case how large language model can be applied for industrial application. Specifically, in this paper, we try to find a working mechanism that allows us to apply the intelligence of the large language model for simulation model parameterization. It's like people are doing experiment and try to figure out how to define the parameter for a process in order to get the best outcome. And similarly, large language model can do this too, but in a digital world. So we created a simple simulation model and find a working mechanism that allows the large language model to observe what is happening in the simulation and then control the progression of the simulation model and then try to find what is the best outcome that we can get from the simulation model. It's intelligent observation and intelligent reasoning and intelligent decision making for make the simulation more useful.
Very good. We're going to come to those elements, especially interested in the reasoning, intelligent. Sure, we're talking about AI, supposed to be intelligent right now. Let's dive in to the paper. You write that you come up with a novel design of a multi-agent system framework that applies the large language models to automate the parameterization, as you just said, of simulation models. Let's first start with the agent, if I may. What is an agent? What exactly is an agent supposed to do? Maybe in general and more specifically in your use case.
Yeah, let me start explaining the agent in a more intuitive way. For example, if you want to travel from Stuttgart to Berlin and you want a ticket, you went to the travel agency and ask our agent, please give me a ticket. I want to travel there. And you are specifying a task for the agent to accomplish. And the agent use his knowledge, and maybe there is a standard procedure that he analyze your requirements, your needs, and accomplish your task. Maybe he need to check the schedule and find the best timing for your travel and give you a travel plan. That is something similar that the agent is doing in the digital world. The agent is a software component. It processes input information and generates the output information in order to accomplish a task. So why we use this concept multi-agent system? But firstly, the agent. So we try to create a digital agent that is enabled by large language model. The large language model interprets your need in natural language, or maybe also in code, mostly because the large language model can only understand the text. And it understands your text, interpret it, and analyze it, and generate an output. This output can be utilized by either by other software component or by human. Just you get the analyzed result or the desired outcome. That is the agent.
Very good. Interesting that you make that comparison to the travel agent. It's interesting. We talked about language at the very beginning when I asked you how to pronounce your name correctly. And I made this comparison to, complete different language in the ex-Yugoslavian. Now, in this case, I'm making another comparison because I believe that in the English language, which is, I believe, not your first language, it's neither mine, I think the word agent, exactly as you use it, is used as the example of the travel agent. I don't think if we translate it, for example, into German, I'm not sure about French, other languages, or maybe into Chinese, if that if that stays the same. But that's a very good comparison. So you say, imagine there is this person who does all the steps necessary and comes back with a solution, with a proposal to me, right? And that's what the piece of software is going to be doing for me. Now, you already also mentioned, we talked about intelligence, and you already mentioned the word reasoning. You say sort of framework, you talked about understanding, and the framework features specialized large language models, agents tasked with observing, reasoning, decision-making. Those are all cognitive activities, so to say, which typically, and we don't want to go into the philosophical question because I know you must have had that discussion in the last years many times.
Yes.
But you do say, I do want to stay with this reasoning, which certainly from a specific perspective, certain listeners will say, only humans can reason. You want to hold against that there is a certain way of reasoning that very well pieces of software agents can do?
Yeah, because the reason has a specific meaning in different contexts. For example, for mathematician, if you talk about reason, he or she when thinking about logic system, logic reasoning, and rules, and there's already very established formal framework how reason can be carried out in a rigid way. But I will go from another perspective. It would be better to think about the thought instead of the reason, and what is the relationships between the thought and the language. I would say the large language model can think because it's basically the same mechanism how human thinks. It has something to do with what the relationships between the language and the thought. I would say a thought is a progress, and the language convey this thought. And for example, I'm talking now, you're hearing me, and I have something in mind. I try to express this with my language. Maybe my language is not perfect, but it doesn't matter as you get the meaning. And if I now suddenly stop, your thought stop, right? Because the thought is a progress, and it's something dynamic. Actually, that is exactly the same working mechanism how large language model understand or interpret the language. So it consume the token more simple way. It consume the token, so each by each. So the first word may activate some neuron activation in the large language model, and then comes the next token. And then the second token trigger also some neuron activations. And this change of neuron activation is a thought of the large language model. And this is actually a quite similar mechanism. And that's also the reason I believe why large language model works technically. And it's, from my opinion, the large language model can really understand the thought based on the interpretation of the language.
Very good. And not everybody is going to agree with that, and that's perfectly okay. At least maybe not until here. And maybe, who knows, in the next half hour at the end, they are going to agree. Of course, we have the big advantage that what we are going to be talking about is in an industrial environment. I think it's a lot more difficult, the topic, although we can start from the same principles if we talk about, let's say more the consumer space and things that humans do between humans. And let's keep it at that for the moment. And we are going to make one step back anyway, because this is all for the sake of digital twins, right? Or to put it differently, you've been working with digital twins, and that we understand later on what exactly the agents can help you do with digital twins. So, of course, same question again. What is a digital twin, and what is the use in our industrial environment of a digital twin?
Mm-hmm. Actually, there is a strong need why we need a digital twin for intelligent automation. It's because, specifically for large language model, it works in a digital environment. It can only understand data and generate data. There must be a bridge that bridge the cyber world and to provide the data for any intelligent algorithm. So the digital twin is a synchronized digital environment, or actually digital twin is also a software, and it provides a synchronized data for other software component in order to make this intelligence software being able to analyze what is really happening in the physical world and create some desired result for application.
Very good. Now you mentioned two, and yes, I mean, I always come back to, I did actually do my computer-aided design in an architectural environment, and maybe the architect is the oldest digital twin producer of the world. I don't know. I assume, but I'm not certain, that thousands of years ago, people did maybe, make images on walls or whatever they did. Maybe, or at least maybe they were started at some point, and I'm thinking about what they were going to build before building it. And that's kind of maybe where that started. Now, you mentioned two primary parts of the digital twin, being the information model and the simulation model. So let's find out what they are. The information model. So when I hear that, I hear two things. My brain reasons two things. Number one is immediately, as we are very strongly involved, Robert, myself, in OPC UA, as an example of a technology architecture around an information model. So question would be, does it happen to be, or is it just some other one? That's perfectly okay as well. And the second one then is, shall I say, maybe at least in my bubble, the last year maybe, endeavor of the large language community to minimize large language model hallucinations by having the model trained on organized data, right? Be it on graphs or, information model in general. So these are the two things maybe you can comment on, talking about the information model.
Actually, in this paper, I make this division of the concept. One is information model, one is simulation model, just for the purpose of working system design. So the information model is descriptive. You can think about newspaper, but it's not a daily newspaper, but secondly, a newspaper. It's generating, I would say, a description of the world or description of all the production facility every second, so that the large language model can understand what is happening now. And the simulation model is predictive, so it's dynamic. It's trying to predict what will happen in a short future, and because we want to predict something and make the good decision. So this distinction between the descriptive model and the predictive model, so I use different terms, information model. You also mentioned the OPC UA. But yes, OPC UA actually is an enabling technology that allows us to integrate the large language model in industrial automation, because it's the large language model requires the data to interpret and analyze. And I also did a lot of engineering work in our laboratory. I tried to connect different automation components to the digital twin, but it takes me too much time. And since I use the unified middleware, the unified communication protocol based on OPC UA, the world has become so friendly to me. And I can just have one client data point created through OPC UA and can access all the data. Actually, the reason I use OPC UA is because it's provide a unified communication interface, and it allows me also to set the data in order to manipulate the automation system. That is for the first question. And the second question, can you maybe repeat the second question? Because it's a bit of it.
It's my mistake asking too large questions.
No.
It's like, how do we call that? When we give the large language model, we give it the option to maybe a complete book right at the beginning. So maybe that's what I do as well, right?
No. Actually, I remember that point.
Oh, there you go. There you go.
Yeah. So along with the OPC-UA data model, that is not enough because this data is less in meaning. I mean, if you want to make large language model being able to interpret what is happening in the field level, this number 0, 1s and this technical name from the OPC-UA, that is too difficult to understand. That is even also too difficult to understand for our human technician. And we need to find a way to enhance the semantics of this data and to make this data piece of information. That is the difference between the information and data. So when we're talking about information, we mean something that we can understand. This process require a semantic enhancement process. So we need to describe what does this data mean? What does this data change means? Maybe a bit flip from 0 to 1 means the model is on the field device level. But on a higher level, for example, in the automation module level, it means the conveyor belt begin running. Or even a higher level, we think about production line, that basically means the logistic process has begun. So there are this context difference in each abstraction level, and we need to annotate this semantics. What does this simple data change means in different contexts? So the most important thing is we need semantics in order to make the data more interpretable.
Right. The second question was actually a different one, so I will repeat it. I think the human readable description of what, variables X, Y, Z, X at something mean is exactly possible with OPC-UA right now. The question I asked, the second one, but excuse me for my large questions. Now, what I've seen, it's only for a couple of months, half a year in my bubble, is this huge endeavor of starting with organized data. Typically with graph technology is the example. And then to, again, do the comparison. But that's not important, really not. But it's just as that people say the information model of OPC-UA is a graph as well. So, but the question was, and what we see is that the reason the community does that is to bring down hallucinations of large language models. So that's what I was looking for also. If you confirm that you say, yeah, sure, if we have organize information in an information model, then what later on, and we're going to come to that, the agents are going to be doing, the chances of getting something weird, let's say, are going to be smaller, or in the end, hopefully, zero.
Yeah, the hallucination. Actually, I understand this problem in a different way. So the hallucination is an oversimplified term to say the large language model doesn't accomplish its task. So there are different types, if we look closely, different type of hallucination. Maybe it's because we didn't provide enough context or we didn't provide enough input information. So large language model has many possibilities to generate an output based on the ambiguous input. That is, we can also call it as extrinsic hallucination. Something happened outside the large language model, basically because it doesn't provide enough information. And there are intrinsic hallucinations. Say the large language model is not good enough, it's not knowledgeable enough to understand what it has been told and failed in produce the desired result. And there are another hallucination, a little bit different. It's because it doesn't generate the desired result. So when we ask some question, we have some expectation what we want. If the large language model generate everything based on the fact till the generated text is correct without error, but it doesn't satisfy the requirements of the user, just maybe like the way that I talk, given long speech just now, it doesn't really address the intended question. We can say that is also a hallucination, because the large language model need to align with the human desire and the human intent, or with the human value. That is actually also an important problem that we try to solve. So how to align the large language model to address the intended input? There are generally these three types of hallucination. Each hallucination, I would say, has different characteristic and have different method to address. Again, the OPC-UA can provide the real-time information and make the large language model more informed of what is happening in the physical world. But we still need to enhance the semantics of the OPC-UA so that we can provide enough information and context to the large language model for its task.
Okay, well, I'm going to assume for the moment that when we come to the agents later on, that when people are going to be using your system, that they're not going to have any of those. And we're not going to stay now too long with the topic. Yeah. So the next thing is then the large language model. So what you already mentioned, you've been on this track for quite a long time. So what is then the use of large language models in relation to digital twins?
Basically, the digital twin provides the digital environment for large language model. And digital twin should be a high fidelity replicate that represent the physical world, and it is synchronized. So we have this bridge, this connector between the large language model and the physical world.
Okay, and what does it do? Is that then aspiring domain experts? Because now, through the use of the large language model, I can do things which maybe until then only somebody else, maybe who had 30 years experience or with different capabilities could do.
I would think this proven in a different way. So I think the large language model is more in the role to assist the human. There is also a reason why the developer always include a user in their application. The first reason is this large language model is not accountable. It always requires the human supervision to validate the output. And the second reason is that actually the large language model is not reliable enough. It has a lot of knowledge, but it sometimes generates, as I said, it's a hallucination. So we always need this experienced expert to validate the result. And so basically it enhances the productivity of the expert. It doesn't have to write the sentence themselves or make the calculation to create a text themselves. Their job is swift to validation of the generated text. We still require the human expert in this loop.
Mm-hmm. Or maybe an agent?
An agent, yeah. So if we look at the market or the application on the market, this agent always serve a user. And I don't think it's feasible in the next 5 or 10 years that it will replace a human, because we need the accountability. Some people have to be responsible for the system we developed and for the text that the agent generated. That accountable person is either the user or the developer. And I don't think the large language model is so safe, is safe enough to have this 100% reliability. So we always need a human.
And that's why you come up with a multi-agent framework. So what is then the combination? What is the role of the agent? What are then the multi-agents? And you also bring up a concept of divide and conquer. So maybe you want to talk about the combination of those 3 specific elements of your paper.
Mm-hmm. Yeah, the divide and conquer is a common method we use to solve complicated tasks. And actually, that has something to do why we need the multi-agent. It's because if we want to solve a very complicated task, we need to decompose this complicated task into several simple tasks that we can conquer. And if there are some subtasks that cannot be solved, then we say this whole big problem is unsolvable because that particular part is unsolvable. And if we don't use the divide and conquer this method, we human sometimes don't know how to solve a problem. And that is a general method that we always use. So if I now give you a very complicated task, I say you are not allowed to divide this complicated task into some subtasks and conquer them one by one. Then you might find it too difficult. It's even impossible for our human to come up with any solution to this. And that also the reason why we need a multi-agent system. So we try to divide complicated tasks into several smaller tasks, and each subtask should be solved by a specific agent. And each agent has some subtasks. Maybe the first agent is just trying to analyze or interpret the data and generate one insight. And the second agent is based on this most important insight and perform some analysis. And the third agent is based on this analyzed result and generate an actionable control command or make a decision. And then we take the final decision of the last agent to control a simulation model. So it's an information processing pipeline that we try to model them into some subtasks, and each agent has a particular responsibility to solve this particular subtask. Then we have a very complicated task solved one step by step. That is basically a principle why we need multi-agent and how we conquer this complicated task.
Very good. And while you were talking, my brain kind of broke it down into subtasks, I guess. I'm not sure. One thought I had was, it's just a week ago that OpenAI brought to market their, I think what they call O1, right? And what is specifically new, as far as I understand, is maybe, and I'm just going to ask you for a similarity or to comment on exactly that it's showing you as a user, I believe, if you want to, right? Or at least it's taking a longer time because it is showing you user exactly the steps it's taking. I'm not sure if that is called chain of thought, tree of thought. You have a couple of specific ways. So maybe you want to comment on that, where you would then say the similarity, maybe if there is, between in your paper, the multi-agent system, maybe that's even further. So I'll stop there.
Yeah, actually, my approach and OpenAI's approach is based on the same principle. So if you use the ChatGPT, it generates a response in a linear time. So no matter how complicated is your question, it generates the answer with the same speed. That is actually very unreasonable because a complicated task has a higher complexity that require more time to solve and more steps to solve. But if a large language model is generating the answer for every question with the same speed, that doesn't make sense, because for a difficult task, we require more steps to accomplish it. And the idea behind this chain of thought is to create this possibility to address complicated tasks with more time complexity and with more steps. And we can do it either with multi-agent system or use the large language model generating multiple round question answering so that we collect enough data for this complicated task, and we extract the most important, the most essential insight, and then generate a decision. So the matching between the time complexity and the task complexity, that is something essential in this method.
Very good. You already mentioned, and very interesting, that things happen, at a similar time around the world from different perspectives, right? You already mentioned the different agents. We'll get into more detail in a moment, but let's speed up a little bit. Maybe you want to give us kind of just an example of, let's say, the industrial environment, without going into much detail, but saying, give us an example of, maybe in your paper or another one, what does the summarization agent do? What does then next the observation, or it's the other way around, sorry. What does the observation agent do? What does then the reasoning agent do? What does then the decision agent do? And what does the summarization? I can almost imagine what it does, but maybe by a very easy example, you can share with the listeners what are the specific differences of these four different agents as an example.
Mm-hmm. Yeah, actually, that's four typical tasks that we need to solve any task. The first agent, observation agent, it reads all the text that is created from the digital twin or provided by OPC UA and try to interpret the meaning of the text and then generate insight. What is the most important part from this information model? What has been changed and what will have the biggest impact? And then another agent that is reasoning agent. It's based on this insight, try to reason what is most important that can influence the simulation outcome in the future, and then derive another insight that's given to the decision-making agent, and decision-making agent is generating a command based on this insight generated. And final one, the summarization agent. In this information processing pipeline, we already have a lot of text. It's more than 2,000 text generated, and the summarization agent spares the effort for a human to read through all these 2,000 words and generate the most essential idea behind all this text. It's designed for human-machine interaction, so it makes the user easier to understand what is the reasoning process of this underlying three agents.
Right, underlying three agents. So your multi-agent framework, understand, has three layers. So there's the user interface with the user, then there is, you call it a middle layer and a fundamental layer. So we can go, and we can do that very quickly, but in the end, and that is then the question and the assumption that the user of your framework, is going to be asking things, is going to be, and that's what we should move into, is going to tell the agent to do things in this industrial environment. And the user, may I assume correctly, is only interfacing with exactly the first layer, and then on the next layers, the framework makes sure that the user will at some point in time get an answer. Is that right?
Yes.
Mm-hmm. So again, very similar, I believe, to but just to make it, what should I say, what we just learned also OpenAI to come up to the market, but maybe very similar. So let's see what exactly you have been doing. What is the use case we've mentioned? And so what have you actually seen that your multi-agent framework is capable of doing? So how have you moved ahead in relationship to how we do things today, so to say, in the factory or before we get into the factory?
Mm-hmm. In this paper, we only present a simple use case. It's a blending process, how we can mix a different particle with different density to create a perfect mixture. It's rather simple, but what we're trying to introduce is a general framework that is applicable for different use cases. For example, if we have in industrial application a simulation model that can predict some outcome And with the progression of the simulation model, we can create some data interface and feed this data to large language model. Actually, the large language model can help you to make a decision how to set the parameter to increase the chance of the optimal outcome. And this multi-agent system powered by large language model can also help making this simulation model more accessible for user. For example, it can explain what is happening in the simulation model, or maybe the user of the simulation application is not an experienced engineer and needs some help. And in that case, the large language model can help answering some question based on the user input, why this is happening and how I set the parameter. And that makes the simulation model more intuitive. And I would call it knowledge enhanced simulation model or intelligent simulation model. And the large language model plays a role of providing this intelligence and knowledge.
Right. Now you have a setup, right? So you show that actually your multi-agent framework does provide additional value. So what is that setup?
The setup is we have a simulation model, and we can create the data interface and control interface. The data interface just provides this accessible data. And control interface provides the possibility to manipulate the parameter of the simulation. And then if we have this two interface, we can incorporate the large language model in this loop to analyze the data and generate the control command and feedback to the simulation model. It's a loop.
Right. So I specifically meant is you're using a simplified container mixing process.
Yeah.
And you're showing that actually, what are you showing? What are you proving?
Yeah. And in this case, the user just need to specify, I want a desired outcome that consists of 30% particle A, 30% particle B, and 40% particle C. And this different particle has different characteristic. And the large language model try to come up with a solution. How can we achieve this user goal based on the interaction with the simulation? It's just like with human.
No, but isn't that where you move things up the ladder? Because normally that's what the human does. So I don't know. So in the factory, and in this case, I believe, what is it? It is particles. Maybe they're M&Ms. I don't know what they are. And the product manager wants to have a different variation of the M&Ms, the particles, right? Or whatever they are. I don't know what you were thinking of. And then the person in the factory needs to think how to get that maybe before. And they do the simulation because that's what this still is about. Now, what you're saying is, and I do come back to, giving, let's say, the domain expert, and maybe in this case, the domain expert is the product manager of the M&Ms. Maybe I go too far, but you tell me. And the domain expert, like the product, in this case, M&M product, he or she wants to do, two weird colors, things in a certain mix. And it's just going to give that. And you say the LLM in the combination of your multi-agent framework is going to come up with a solution, which typically today there is a human involved, and the human needs to decide how to produce that specific new product for the market, right?
Not the manager of the factory, but it's more maybe the customer of my research is the manufacturer of a machine, or say a simulation software designer or developer. They want to make their simulation model more useful for customers that don't understand the technical detail, and this technical detail, the knowledge can be provided by large language model. And maybe the customer could be some system integrator. And they can design the production system a very intuitive way by enable large language model interface, allow user to interact, and the system automatically come up with a solution based on some problem description. But the factory manager just use this. They are the user, so they can buy this intelligent machine or intelligent simulation model, and this system can provide more value and make the process more efficient.
Yeah, I assume that's what I always do. I already went one step further. Sure, because, I mean, in the factory somewhere, there's a white-collar person sitting, and that white-collar person is in charge of, producing a new solution for the market. I just stay with my M&Ms here. I don't think we can buy M&Ms as such here. It doesn't matter. But I mean, that's then the next, but we keep it at that. That's perfectly okay. I think we've understood what it is. Now, okay, so let me see then where we move from there. I think what is the important question for me? Well, one I had in between actually as we're talking. Me originally Dutch, you originally, I believe, Chinese. We both talk in English. What are the different elements of your solution? What do they talk? So what does the user talk with the agent, number one? And how do the digital twins and the agents communicate? What are the different languages, the different means of communication in your proposal?
So basically, the large language model can understand different language, and no matter it's a code or natural language, in German, English, Chinese, it doesn't matter. What really matters is knowledge behind this language and the thought behind this language. And actually, it's quite easy to make a large language model to understand the language. And if it understands some idea in some English form, it can also translate into Chinese, or understand the reason of a code can also translate into a natural language. It doesn't matter. I also believe that large language model can enhance the international communication. And there are a lot of good ideas in English, and we can easily, by using the large language model, translate into the English. And if people use large language model, it has a repository of the word knowledge. And no matter what language, you access this language, this word human knowledge, collective knowledge, and it makes this knowledge really consumable for the user. You just need to specify what you want to know, and large language model provides you this information on demand. That is the most powerful thing of a large language model. I also believe the large language model can prepare the human knowledge and across the language barrier and border, and to make our world a better world in the future.
That would have already sounded like a great close-off, but I'm still going to ask you, as I always do. And in this case, I do have a very specific interest, so to say, as well. So, sure, I want to know from you, what is the global, what is the perspective today, future? So, where are these LLM, large language model based multi-agent systems going to bring us, in our industrial world, right? Because that's our specific interest. And maybe where are we today? You went to, I assume yourself, probably to part of Italy. That was just one example, I guess, of, in this case, an IEEE, which is, I believe, a US-based global organization, nevertheless. So where would you say are we standing today around the world? You are now working based in Germany, I assume, but you will tell me, and our listeners, if you still have a strong link to China, where are exactly these LLM agent-based activities in relation to industrial? Where are we in Europe, in Germany, in China, in the United States, or elsewhere? And where are they going to bring us?
Yeah, maybe the first question, what does this multi-agent system bring to the technical system in industrial automation or industrial application? So I really like science fiction movie, and I like philosophies and think about different things. I have a dream that in the future, maybe all the technical system can be enhanced with intelligence, with the knowledge that we have during the human history. There was a science fiction movie that describing the human is traveling interplanet, and they have one medical machine in the space ship that can perform medical operation. If someone get wounded, it's just get into the capsule and get operated. That machine, if in the future we want this machine must understand the human knowledge and understand how to perform operation and hear the human. And if in the future we want to have this knowledge enhanced technical system, we need to incorporate the knowledge of human into that machine. But one specific possibility we have already now is a large language model. It can provide the knowledge on demand. And if we find a feasible system design that allows us to utilize this intelligence, this knowledge, then we can make the machine more intelligent. And actually, I also hold the opinion that the technology should serve the human, and it should be human-centric. And human develop the technical system based on its desire. And maybe in the future, with maybe it's still require times 5, 10, or 20 years that we can have the first prototype of this sort of machine that can that is equipped with intelligence and can user just need to specify their need and the machine does what the human want. That is my dream, and that I surely believe it's worth more of my research, some more years of my life in pursuit of this dream. And yeah, that is for the first question. Maybe I dream a little bit about it. But the second is about the international situation, where is Germany. I received my financial support from Stiftung der Deutschen Wissenschaft. The money comes from the Bundesministerium. And it supports entrepreneurship, not only economic entrepreneurship, but also social entrepreneurship. When I look at the research intensity, international environment, actually 5 months ago, we performed a literature review on the papers or the research activity around the large language model in industrial application. We find out in Europe there are 40 research papers. In USA there's 150, and in China there's also 150.
Is that in industrial space, or what topic is that?
Yeah, it's a topic about large language model application in robotics and automation. I think that result aligns to my impression. So speaking of the research intensity, German or Europe is left behind. And the most result come from China and come from the USA. And you also mentioned you met a lot of Chinese researchers. And actually, if you look into the author list of this papers, you always find a Chinese name in the author list. It has something to do with the education system. Actually, in Germany, if a student don't like math, it can abandon or just don't pick this subject. But in China, every student has to learn the math because it's obligatory. And actually, in China, there is a lot of researchers researching in how to promote the artificial intelligence. The research intensity is quite high. And there is also a benefit for this. We in China has unified language. In order to communicate, we don't have to translate any language. Actually, I read the Chinese article quite often. And the information intensity, I would say, maybe it's 10 times higher than here in Germany. And I read fast in Chinese. But when we look at Europe, it's, the language, I would say, is divided. So the communication is also divided. And maybe there are no enough creators that create this content that can be shared with a unified market. And from the economic perspective, the knowledge sharing in China is, I would say, is cheaper or easier. And the knowledge sharing in Germany or across Europe is more difficult. But that is also true for USA because they have unified language and it facilitates the communication and information sharing significantly.
Thank you very much for this wake-up call on one side. I can only say we are a global podcast. You Chinese, you American, you from anywhere. Listeners, please keep up the good pace. You Europeans, drive up the pace as Yuchen is suggesting. Thank you very much. Yuchen, let's not forget what you were sharing with us today, your multi-agent system. I'm a huge believer that that agents are going to be so helpful to us in general and to us specifically in our industrial environment. I also love these movies that look into the future. Let's hope it's not going to be similar to the 2001 Space Odyssey, which I was just talking about with Håkan, a good friend of mine, last night. You recall Stanley Kubrick, 1968. That's how long ago was that? That's 50 years ago, because in that one, robots are taking over the world, right? So we're not going to keep it at that as our final. I thank you very much. Congratulations again on your paper, and I only hope that it's going to be, a stimulus to the listeners to, to build further on what you and your colleagues have done. So those listeners that are interested, we're going to share your name in the podcast notes, Yuchen Xia. I still hope that I say that correctly. And we're also going to share the GitHub repository. So for, again, having said that, the people that want to build further on what you've done, they can go to GitHub. So thank you very much, Yuchen, and hope to see you somewhere. Good luck with your research in Stuttgart or elsewhere.
Yeah, thank you. It's my pleasure.
Thank you, Yuchen. Bye-bye.
Bye-bye.